Solving trig equations involving radians. A summary of all the rules based on symmetries for sine, cos and tan in radians. So in this example, the first thing we see is that the angle is 2x in the equation, but in the interval given it's x. So I need to match this to this. So don't modify the 2x, leave this one alone. So I need to multiply by 2 here, here and here. So times 2. And the decimal equivalent for minus 2 pi and 2 pi, well, we've got these are going to be quite useful. So we need to solve using this interval. So ignore the one that we started with. So we're using the interval for 2x. So on the calculator, when we do cos inverse of the, and that's your cosine ratio there, it will give us an angle, and this angle represents this. It's 2x. It's not angle x. Okay, it's 2x. Everything we work out will be angle 2x. Right at the end we can divide by 2 and get angle x. And if I change the sign on this angle, I've got another angle, and this one is also valid. Both are within this interval. And the 0.64350, if I add 2 pi, it will take me outside this interval, so I don't want that one. If I subtract 2 pi, so minus 2 pi, minus 5.63, and that's within the interval, so I want that one. And this angle here, the minus 0.64 angle here, if I add 2 pi, I will get another valid angle, and these are the only ones which are valid within the interval, but they all represent the angle 2x. Okay, so we're looking at angle 2x. So we're not using this for anything at this stage. Okay, so if I make a list of all these, all of the valid angles, I get this, and then divide by 2, and we have our final answers here, angle x. And we can test these. I mean, these are rounded values, so if we try this in the original equation, we have, and this is in radians still because these angles are in radians, so cosine of minus 2.82, I need to multiply by 2 because it was 2x, and this is angle x. I just need to put a times 2 in here. That's close enough to 0.8. It is a rounded angle after all. If I try another one, let's try the next one, 0.322. That's close enough to 0.8 as well, so these angles are valid. For practice, try these questions.